In this video, we're going to be talking about how to calculate population z-scores. I'm going to give you a couple different formulas to work with, and I really like this. This is fun. So z-scores transform raw scores into units of standard deviation either above the mean or below the mean. And transformation provides a reference in the standard normal distribution. So we need to be using a normally distributed bell curve distribution for this. The scores on the left side are said to be below the mean, and the scores on the right side are above the mean. There are two pieces of information that a z-score tells us. First of all, a z-score will either be positive or negative, and this will identify whether the score is above the mean, positive, or below the mean, negative. But a z-score is also a number, and that number specifies the distance of the score from the mean using standard deviation units. So how many standard deviations away from the mean is this particular score? Here's the formula for z-score, and it'll look a little bit familiar to you. So in the numerator, we're going to talk about that first. We basically have a deviation score. So we take the score that we're interested in and we subtract the mean. That is the numerator of the z-score. It's a deviation score. It measures the distance in units from the score and the mean. So how far away is the score from the mean? And this will tell us if the score is located above or below the mean, because if our score is larger than the mean, this deviation score is going to be positive. But if our score is smaller than the mean, the deviation score is going to be negative. So this is where you're going to get your either positive or negative sign in your z-score, is in the numerator. The denominator of this z formula are standard deviations units. So we use the standard deviation that divides into the deviation score. I know that's a lot of deviation there. It represents the difference from the mean and standard deviation units. So our denominator is our standard deviation. So a pretty easy formula. I know you might be looking at this and like, oh my gosh, but no, it's easy. It's everything you already know how to do. Take the score, subtract the mean, and divide it by the standard deviation. That gives you the z-score, the score's sort of address in the distribution. So we're going to go ahead and practice with this. For a distribution with a mean of 40 and a standard deviation of 8, we're going to find the z-score for each of these following scores. Let's take a look. So I've provided the z formula for you here. We have z equals the score minus the mean divided by the standard deviation. And as a reminder, we had a mean of 40 and a standard deviation of 8. We have all the information we need to be able to figure this out. So let's plug in the numbers. So we know the score is 36. We know the mean is 40. And we know the standard deviation is 8. Now, first of all, I know I'm going to have a negative z-score because 36 is less than the mean of 40. And it's true, 36 minus 40 is negative 4. And I'm going to divide that by the standard deviation of 8. And so my z-score in this case is negative 0.50. So my z-score for a score of 36 means basically half a standard deviation below the mean. The standard deviation is 8, and my score is 4 below the mean. Half of 8 is 4, so that means our z-score is a negative 0.50. Let's take a look at the next one. For this next one, we have a score of 46. So let's plug it into the formula. I'm going to plug in the score first of 46 minus the mean of 40. And I'm going to divide it by the standard deviation of 8. Now I know by looking at this that I'm going to have a positive z-score because my score is larger than the mean. So 46 minus 40 gives us 6. And 6 divided by 8 is 0.75. So we have a z-score that's equal to positive 0.75. Now if you think about it this way, 8 is the total standard deviation, that's one standard deviation, and 6 is 3/4 of that. So if my difference between my score and the mean is 6 points. That's 3/4 of a standard deviation. So my z-score is equal to plus 0.75. My score is 0.75 units away from the mean. Let's do another one. For this one, I have a score of 56. I'm just going to plug it in, my score minus the mean, divided by the standard deviation. So my score minus the mean of 40 gives me 16, and the standard deviation is 8. 8 goes into 16 twice, so my z-score for 56 is a positive 2. That only makes sense because if my score is 56, minus 40 is 16, and the standard deviation is 8, 16 is 2 of those, right? So my z-score is a positive 2, meaning my score is 2 standard deviations above the mean. One more. For this last one, my score is 24. So I'll plug that in first, 24 minus the mean of 40. Whoa, I'm way below the mean, aren't I? So I know I'm going to have a negative number. 24 well, let me put this here first. 24 minus 40 is negative 16. And 8 goes into negative 16 negative 2 times. So my z-score is equal in this case to negative 2. Again, just makes sense. 16 is exactly 2 standard deviations. 1 standard deviation is 8, 2 standard deviations would be 16. So my z-score is a negative 2. I am 2 standard deviations below the mean. Sometimes we're going to be solving problems where we know the z-score, we know the mean and the standard deviation, but we don't know the value of a particular score corresponding to a z-score. So there's 2 different ways you can do this. You can solve for x using algebra, which I'm going to demonstrate for you, or you can use this easy formula. I want you to write this down and keep it close to you. If you ever need to know a score, all you need to do is multiply the z-score by the standard deviation and then add the mean. And this will make sense as we do some of the examples. So in these next few examples, I'm going to use algebra first, and then I'm going to use this easy formula. So let's go back and see what we're going to look at. So we have a population with a mean of 62 and a standard deviation of 12. I want to find the score values that are at these following z-scores, negative 0.25, negative 1.50, positive 0.5, and positive 2. Let's do it. Okay, let's take this first example. Let me show you what we have here first. We have the formula for z, which we had before, but this time we're going to be solving for x. So I have x circled in this case. We have a new mean of 62. We have a standard deviation of 12. I've also included this other formula I talked about. We'll work with that later. But right now we're going to solve for x using very basic algebra principles. I'm going to walk you through it, but I'm going to also reiterate that this formula will not let you down. If you don't like doing the algebra, this formula is your best friend. So here we go. We have z equals negative 0.25. I know that. So I'm going to put that in the equation right there. And it equals, we don't know x, so I have to just keep x there. But I know my mean of 62, and I know the standard deviation of 12. Now my goal when I'm using algebra is to get x by itself. So just a reminder of some of the rules of algebra. To get rid of this 12 in the denominator, I can multiply this side by 12 over 1, or 12. But what I do to this side, I have to also do to this side. So if I multiply 12 over 1 by 1 over 12, basically, I'm getting rid of the 12. And then I have to multiply negative 0.25 by 12, and that'll give me a negative 3. So I'm going to put negative 3 equals x minus 62, and I can get rid of these parentheses now. So now I still want to get x by itself, so I'm going to keep the x there, but I'm going to add 62 to cancel out this negative 62. So I'm going to add 62 here, and that just basically wipes it out. But whatever I do to the one side, I have to do to the other side. So I'm going to add 62 to negative 3, and that gives me a x of 59. I know this is backwards, 59 equals x, but it's the same thing. So our score in this case, our z-score of negative 0.25 gives us a raw score of 59. So let's use this formula. You can tell me if you think it's easier. I do think it's easier. So here we go. I don't know the score, but I know the z is negative 0.25. I know the standard deviation is 12, and I know the mean is 62. So I just do what I just did up here. Negative 0.25 times 12 is negative 3 plus 62 gives us an x of 59. So you can use algebra or you can use the pre-made formula. Let's try another one. For this one, we have a z-score of negative 1.50. We want to figure out what is the actual raw score associated with that z-score. We don't know it. So I'm going to plug in what I do know. I do know that z is negative 1.50, and that is going to be equal to whatever score it is, minus 62, the mean, divided by the standard deviation. So we have to do, again, the same thing we did before. We need to get x by itself. So I'm going to multiply this side by 12 over 1, and that basically cancels it out. And what I do to this side, I have to do this side. So 150 times 12, basically, it's negative 150. So it's going to be negative 18. So we have x minus 62. I need to get the 62 on this other side, or the negative 62. To do that, I'm going to add a positive 62, and that cancels that out. And if I add 62 here as well, 62 minus 18 gives us a total of 44. So in this case, our x is equal to 44. So let's check it out here and see if it worked. We have x, which we don't know. We have the z of negative 1.5. We have the standard deviation of 12, and we have a mean of 62. So again, negative 1.5 times 12 gives us a negative 18, and a negative 18 plus 62. So basically you're saying 62 minus 18 gives us 44. So our x is 44. In our third example, we have a z of positive 0.50. So let's plug everything in. Z is on the side, positive 0.50 is equal to whatever x we're looking for, minus 62, divided by 12. Okay, so we have to get 12 on this side, so we're going to multiply this side by 12 to get rid of it. And we're going to multiply 12 times a positive 0.5, which gives us 6. So we now need to take our negative 62 and add 62 to both sides to get rid of it. So 62 plus 6 is 68. So in this case, our x is 68. So let's check it out with the formula here. So let me get rid of some of this. There we go. So we know our x is equal to our z of positive 0.50. You don't need to put a positive there, I just do. And the standard deviation of 12 plus the mean of 62. So we have a half, basically, times 12 gives us 6 plus 62, and that gives us 68 for our x. Pretty easy, huh? For this last one, we have a z of 2. Let's plug that in. So we have 2 equals our score minus the mean divided by 12. I'm going to multiply 12 by both sides to get rid of the 12 here. So now we have 24 equals x minus 62. I'm going to add 62 to each side to isolate it here, 62 there. All right, so in this case, our x is equal to 86. Let's try it with the formula to see if it worked. Let me do some erasing. Here we go. We don't know the score, but we do know the z-score is 2. We know the standard deviation is 12, and we know the mean is 62. So 2 times 12 is 24, plus 62, and that gives us an x of 86. There it is. So now you have a good idea of how to calculate a z-score for populations, and in the next video we'll talk about z-scores for samples. So hopefully this gave you some good practice with calculating z-scores for populations and then finding raw scores based on a z-score. In the next video, we'll talk about sample z-scores. See you there.